Okay, starting chapter 10, lesson 10.1. We are starting to talk about the topic of circles. The round objects you know of. Circles. In 10.1, we're going to be talking about lines within a circle, lines that go through a circle, and lines that touch a circle. It's all about lines and circles in 10.1. If you look here at this figure, you can see a bunch of different types of lines within or around a circle. And I'm sure just by looking at this figure, you can come up with the definitions on the left. I'm going to write down the definitions, the formal definitions. If you want to pause the video now and try to take a guess, that might not be a bad idea. Take a guess at each word. But I'm going to go through it. Starting off with a chord. A chord in a circle, a line in a circle, is a segment whose endpoints are on the circle, or on a circle. Okay, so for example, this chord has endpoints here and endpoints here. If I drew another figure, another circle, pretend that's a perfect circle, I know it isn't, and another chord, it could be right there, or another chord could be right there, as long as it doesn't go through the center of that circle. Okay, so chord, actually no, I take that back. I take that last part back. A chord, it just has to have endpoints on a circle. Okay. Next is secant. If you look at the figure, look at secant. There's a difference between a chord and a secant line, because a secant is a line. Remember the difference between a segment and a line that intersects a circle in 2 points. So our figure, you can see a secant, it's a line going through that circle. Again, if I were just to draw another one, secant could go right through here. It just has to go through the circle and intersect twice. So there's an intersection, there's an intersection. If you look at our figure, it intersects here, and it intersects here. That is a secant line. You know, tangent. I know this might get a little confusing because we've seen the word tangent before when we were working with right triangles and trying to find angles or side lengths given an angle. Tangent now, when working with a circle, is a line in the plane of the circle I'm going to respell plane, that's bad right in there. Plane. In the plane of the circle that intersects at exactly 1 point. If you look at our figure, intersects right there. Okay. Moving on. The radius, if you look at the radius, the definition of radius is they don't give me a definition, that's fine. I'll create my own. The definition of radius is it's half the diameter of a circle. It goes from the center point of the circle to any point on the circle. So the radius is a segment that goes from the center of the circle to any point on the circle. You know, you should have seen the word radius before. You should have most likely worked with radius. Okay? Up here in our figure, okay, look at radius. It goes from the center to this point. That is our radius. Again, if I were to draw another figure, another example of radius, start from the center, pretend this is a perfect circle and that's the center, and just go to any point. That's the radius. Okay. Next is diameter. Diameter is actually a chord. Remember the definition of chord. A chord that goes through the center of a circle. Here, look at diameter. Okay, it is a chord, right? It's a segment with two endpoints on the circle, and it goes through my middle point, right through the center. Again, if I draw another figure, pretend that's a perfect circle, and the diameter would have to go right through the center. Pretend that's through the center. Okay. That is diameter. Okay, let's go down here. There's a few more things that we should identify. First, circle, right? We're working with circles. You should know what a circle is. A circle is the set of all points in a plane that are equidistant from the center, or from a point called the center. Basically, all that means is if you are given a middle point, okay, that's it as a point, call it the center, each point on this circle should be the exact same distance from that point. Now, I know that's not the case in my figure because I can't draw a perfect circle. That is the definition of a circle. The center is just that point. Right? The center is that middle point. We went through the next 5 definitions: center, radius, chord, diameter, secant, tangent. The point of tangency we did not talk about. The point of tangency, I'll give another example of tangent here. Here's a circle, a tangent, oh, that's bad. We'll move that. Goes right by my circle and it touches it exactly 1 point. The point of tangency is that point. Okay. I'll say where the tangent line intersects the circle. Okay. The next 3 definitions are down here. So we'll start with tangent circles. I'll read it. In a plane, 2 circles can intersect in 2 points, 1 point, or no points. Coplanar circles that intersect in 1 point are called tangent circles. So if I have 2 circles and they intersect at exactly 1 point, we see a great example right down here. We see 2 actually, great examples right down here of the tangent circles. If they intersect at exactly 1 point. This might be a little confusing. This is one example. Okay, see how I have 2 different circles? They both intersect right there at that point. This is another example, right? They both intersect at that point. Those are tangent circles. They intersect at 1 point. Coplanar circles that have a common center are called concentric circles, which is right here. It's just a big circle and a little circle. And they have the same center. It looks like a target. Those are concentric circles. Actually, a great example of this would be a dartboard would work, or an archery board. Okay, those are concentric circles. The last definition is a common tangent. Now, this is what I want to talk about because I feel like this can get confusing. A common tangent is a line segment that is tangent to 2 coplanar circles. So here's a great example I'll draw. Okay, here's a circle, call that the center, and I'll just do a little or smaller circle with that center. Okay, a common tangent, remember a tangent is a line that goes by a circle and touches exactly 1 point. A common tangent keeps going and touches both circles at their tangent point. Notice it's the same tangent line. Okay. Another common tangent of these 2 could be right here. Pretend this is only touching at 1 point. Sorry, it's a bad drawing. And this point. All right. These are common tangents. Another common tangent could go through this point and, oh, that's a bad one. I'll delete that line. It goes kind of like this. I'll pretend that's only touching at 1 point. Okay, or like this. Okay, there's 4 common tangent lines in these 2 examples. Okay. Now, there's types of common tangency. There's internal and there's external. Internal tangents intersects the line segment that joins the center of the 2 circles. So, for example, I'll go internal tangents. Oh. Let's just say I have two circles. Okay, there's your center. Pretend there is an invisible line that connects those two centers. Pretend those are being attached by that blue line. The internal tangent intersects that line. So I just gave an example of the internal, or of a tangent line. We'll say it goes like this. That touches that line. I'll redo it since that's a bad drawing. Okay, one more attempt, and then I'm done. There, that's better. Okay. Intersects here, intersects here. That is an internal tangent because it intersected that blue dashed line. Okay. Another example would be the other way. This one. Okay, that is also an internal tangent because it intersects that blue line. An example of an external tangent would be the one up here, right? It does not intersect that blue line. Same with this one. And those are the only four tangents that I can create out of those two circles. I believe, don't quote me yet, but I've yet to see an example of two circles with more than four tangent lines. And I believe there's only four that you can create. Okay? So those two that don't intersect the blue line are external tangents. The two that do intersect that blue line are internal. Moving on. Let's go to some extra practice. In numbers 1 through 6, we're just naming lines. So number 1, name two radii. That's just the radius. Name two different radius. Two different radii. Remember, a radius goes through the center of, or goes from the center of a circle to a point on the circle. Center to circle. So we need a point that starts at the center and goes to the circle. We could call it AB. That's a good example. I'm going to say segment AB. Remember, that's a segment because it doesn't continue. It stops there. Another one could be AF. Next, we have to name a chord. There's two different chords here in this circle. Remember, a chord is a segment with both endpoints on the circle. So an example would be EC, this line here, EC. Another example would be DF. But there are no other examples other than those two. Name a diameter. Remember, a diameter goes through the center of my circle. It's a chord going through the center. There's only one. It's right there. It's DF. A secant of a circle is a line that goes through two different points in my circle. So it's a line. There's only two lines shown here, and it goes through 2 points. Well, it's line DE because it goes through 2 different points. Sorry, line DE. Ooh. almost made a crucial mistake. Next, name a tangent. Remember, we've talked a lot about tangent already, the tangent line. It intersects my circle at exactly 1 point. And right now that's B. Okay. So I'm going to say line through point B. Okay. Name a point of tangency. So there's only 1 point where that tangent line touches, and that's our point. It's point B. Okay. So those are all the different types of lines in my circle. Let's go down here. It says, tell how many common tangents the circles have and draw them. Remember, tangent touches the circle at 1 point. We want to know how many different types of common tangents, or how many common tangents they have. For circles that kind of intersect at 2 different points, there's only going to be 2 tangent lines. One here, and one here. And notice they only intersect at 1 point. You cannot draw another common tangent line between these 2 circles. So there are only 2. And we already did draw them. Now the question is it internal, or are they internal or external? Remember, internal, notice these are the centers, the center of our circle. The internal tangent would intersect that red line there, that red segment. And do our tangent lines intersect that? No. So it is external. Both external. Is it both external? You know, there's going to be times where, like in my example, there's 2 internal and 2 external. And in this case, in this scenario, it's both external. And the last 2. In 9 and 10, they say point D is a point of tangency. It says find BD. So we want to find this length. Something I have not mentioned yet. The point of tangency, if we have a tangent line, it is a right angle with the radius. Okay, so look what we just created. Look what we have here. We have what we call a right triangle, something we worked with throughout all of chapter 9. A right triangle. And we are given 2 side lengths. We know how to solve for BD. We know how to solve for this length if this is a right triangle. It's the Pythagorean theorem. Remember, Pythagorean theorem is c squared equals a squared plus b squared. And our c is a length 10. So 10 squared is equal to, and it doesn't matter which one we choose, 5.54x to go first. Now, what we need to do is use our calculators. We know that 10 squared is 100. .5 squared is 30.25. Okay, we're going to subtract 30.25 from 100. And we're going to get 69.75 is equal to x squared. Now we have to take the square root of that, and we get 8.35. Okay, so our length of BD, or DB, whatever one you want to call it, is 8.35. I'm going to erase this, kind of give me some room. Number 10, point C is also a point of tangency. This is also a point of tangency. We have 2 points of tangency. If BC is 4x plus 6, just label it. Find the value of x to the nearest tenth. Okay. So, let me get rid of this. I'm going to keep 8.35 here. Our points of tangency, both points meet at B. You can create any two types of tangents, two different lines of tangency on a circle. If they meet at one point, which they do here, B, your lengths from your point of tangency to where they intersect are the exact same. So 4x plus 6 is actually equal to 8.35. Okay, they're the exact same. They're equal. So if I were to take my calculator, first thing I have to do is take 8.35. I'm going to subtract 6 from both sides. I'm going to get 4x is equal to 2.35. And I'm going to divide that by 4. I'm going to get 0.59. Actually, it says nearest tenth, so it's 0.6. Okay. If you have questions, please email me, please ask. Go back in the video and take a peek at what you need. Ask me anything you need.